Section 10.2, Quadratic Models. Today I want to focus on being able to find a quadratic model given a sequence. And we talked earlier in section 10.1 about being able to find that quadratic model. And we did a lot of guessing and checking. Well, today I'm going to give you a way to be able to find that quadratic model easily if it doesn't pop into your mind at first. So let's begin by looking at the sequence and determining is it a quadratic or not. Well, if I look at the differences between my terms, 6 to 15, I'm adding 9, 15 to 28, I'm adding 13, and 28 to 45, I add 17. The differences of those numbers, 9 to 13, I add 4, 13 to 17, I add 4 as well. So this tells me that the difference of the differences is a constant, or the second difference is a constant. So that tells me that I'm going to have a quadratic equation. Well, what do we know about a quadratic equation? The standard form is given by y equals ax squared plus bx plus c. Well, how does that work for us? Well, we can replace the y with whatever value we want. We can say a sub n equals a times n squared plus b times n plus c. So n is the number term that we're working with. So what do we know about this sequence up here? Well, we know the first term, a sub 1, is going to be given by a times 1 squared plus b times 1 plus c. We also know that a sub 1 is equal to 6. So 6 has to equal a plus b plus c. The second term is found by taking some a value, and multiplying it by 2 squared plus b times 2 plus c. Notice we've changed that n value because here we're looking for the first term, here we're looking for the second term. And that second term is 15. So we know that 15 is going to equal a times 2 squared plus b times 2 plus c. Likewise, our third term is going to be some value a times 3 squared plus b times 3 plus c. And our third term in this case is 28. So we can clean this up a little bit because we know that a plus b plus c has to equal 6. We also know that 4a plus 2b plus c has to equal 15. And we know that 9a plus 3b plus c has to equal 28. We should realize at this point, as we do a few of these, I suppose, that this left side, this equation, these three equations, are always going to be the same. It's these values over here that are going to be different. But these three values here will always be the first three terms of our sequence. Now we have a system of equations, 3 by 3. We can go ahead and solve for a, b, and c. How do we do that? Well, if you remember, solving a 3 by 3 by hand, we take two of our equations first and we eliminate one of the variables. Then we take two other equations and eliminate a variable there. Well, if I notice, my c's all have a coefficient of 1. So it's going to be fairly easy to eliminate those c values in whichever two equations I pick. So I'm going to go ahead and take my first two equations, a plus b plus c equals 6, and 4a plus 2b plus c equals 15. And I'm going to eliminate that value of c. Well, I can easily do that by multiplying either of these equations by a negative 1. So if I multiply that negative through, I get a negative 4a minus 2b minus c equals a negative 15. Now if I add these two equations together, I'll end up with a negative 3a minus b equals negative 9. Now I've eliminated one of my variables. I'm down to a two variable equation. I come back up to the original set of equations, and I pick two other equations. So I can't do the first two anymore. I can do the first and the last, or I can do the second and the third. I think the first one is a little easier to work with. So I'm going to take my 9a plus 3b plus c equals 28, and my first equation, a plus b plus c equals 6. Again, if I multiply by a negative by one of my equations, distributing that negative through, I get negative a minus b minus c equals a negative 6. Now I can add my two equations together and end up with an 8a plus 2b, my c's eliminate, equals 22. Now I have another equation with two variables, a and b. Over here I had a and b left. Here I have a and b left. So now I have 8a plus 2b equals 22. And I have a negative 3a minus b equals a negative 9. I have a system of equations, two variables, two equations. I can go ahead and solve. If I multiply the bottom equation by 2, that's going to go ahead and eliminate my b values when I add. So this equation, distributing that 2, I get negative 6a minus 2b equals a negative 18. Adding those two equations together, 8a minus 6a gives me 2a, equals 22 minus 18 gives me 4, so I know that a must equal 2. Well, if a equals 2, I can come back into one of my other two equations, plug that value in order to find b. Doesn't matter which equation we use. I have more space over here, so I'll use this equation. So I know that 8 times 2 plus 2b has to equal 22. If I would have noticed, I could have reduced, I guess, that equation by 2, couldn't I have? Divide up 2 by out. My 2 out would have made my work a little easier below. Anyway, 8 times 2 gives me 16, plus 2b equals 22. 2b, subtract your 16 over, I end up with 6, so b equals 3. So now I know that a equals 2, b equals 3. I can go ahead and find my c value. I always go into my first equation because it's going to be the easiest. I have no other coefficients to work with. So I know that 2 plus 3 plus some c value has to equal 6. Well, in this case, I know that c then must equal 1. So what does that tell us? Well, it tells us our quadratic equation. Because we know now, as I turn the page here, that a sub n is going to equal this a value, which is 2, times some n squared, plus my b value, which is 3, times some n, and to that we're going to add our c value of 1. So our quadratic equation is a sub n equals 2n squared plus 3n plus 1.